So, the main goal of this project was to observe how liquids with different viscosities react while being exposed to various sound frequencies. And for those who don't know what frequency and viscosity are, in short, frequency is a repetitive occurrence per unit time, in our case vibrations per second, and viscosity of fluid is a measure of its resistance to gradual deformation. Pretty much, we wanted to measure the wavelength of the liquid surfaces as well as the spread and patterns produced. In order to run our experiments, we built our highly sophisticated test setup consisting of 2 IKEA tables, low frequency speaker, an amplifier, and a computer as a signal input source. For measurements, we used 2 GoPro cameras in slow motion, one shooting from above and another one from the side, as well as a digital camera. For frequencies, we use G major scale starting from G1, and for liquids we kept other properties constant while changing viscosity using cellulose-based thickener. Tikkurila paint manufacturer provided help for preparing liquids and measuring viscosities used in our tests. To measure the viscosity of the liquids, we used 2 methods. First, the 100 ml isocup and a stopwatch to measure the time it took for a cup to be empty, and secondly, a magical device that did all that for us, known as viscometer.
It's called hydroxyethyl cellulose polymer. So that means that it's a hydroxyethyl ether of cellulose, and you can see the structure on the screen. And it's really typical thickener for any paint industry, but also thinking about shampoos, that kind of consumer products also. It's a really old type of thickener, but it's still used a lot because it's really effective. You can have really nice viscosity properties with it. And when we are measuring viscosity, it's really important to use same temperature for each fluid so that you can compare the viscosities of the fluids. If you are measuring fluids with different temperatures, you are not able to compare them, because when we think about the fluid and the temperature, the higher the temperature, the lower the viscosity typically is. The solution which you got contains something that is not toxic, but is biocide anyway, and it might sensitize you. Depends how much you have been in contact of isothiozoles. But it's there because otherwise this cellulose thickener, when it's in water, it would start to grow. Bacteria and mold and things like that, and then it would be really ugly, and you wouldn't like to use it at all, and you wouldn't be able to do your measurements.
Our original hypothesis was that when the frequency goes up, we get more dense ripple patterns, and when viscosity goes up, ripples move slower and patterns dampen faster, thus more energy is needed for similar body deformation. As we can see, our tests are consistent with our hypothesis with overwhelming certainty.